So our really only kind of quote math we're going to be doing today has to do with something called coterminal angles. So this means coterminal, remember from English class, same. So that means they have the same terminal side. So visually, they look the same. So for example, I could have, let me draw that black. Say I have this angle right here. I could have gotten this angle by going a positive 225 degrees or by going a negative 135 degrees. I get to exactly the same spot. Maybe I go to this angle. Well, that's positive 90 degrees or negative 270 degrees. Those are called coterminal angles. So how could I get some other coterminal angles besides just going either the positive direction or the negative direction? Let's go back to that 90-degree example. I get 90 degrees by just doing part of one rotation. So I'm just going here. But what if I went all the way around my circle and then went that 90 degrees? So I've gone 360 degrees, and then I'm adding that 90 degrees. Well, it would really look like the same angle, but I did a 450 degree rotation. What if I did one trip, two trips, and then that 90 degrees? So I did two trips of 360 plus the 90, or I could write out that 360 plus 360. I get 8, 10. What if I did 3 trips? 1, 2, 3, plus my 90 degrees. So 90 degrees plus 3 trips of 360. That would give me 1,170 degrees. So all of these are coterminal. I get coterminals by doing multiple trips around the circle. So what was I really doing? What I was really doing was adding, in this case, but I could subtract as well, adding trips of 360 degrees. Now what would I do if it was radians? We would add or subtract 2 pi. So when we're finding coterminal angles, one thing that's really important, if I ask you for a positive coterminal, I mean my end result is positive, or that my end result is negative. Positive doesn't mean I was adding, negative doesn't necessarily mean I was subtracting. It's about the end result. So if I want to find some positive coterminal angles of 45 degrees, let's do 45 plus 360. That's one more trip. So 45 plus 360 gives me 405. I need one more because I asked for 2 positive. So I'm going to do 405 degrees plus 360 degrees. And that gives me 765. So those are my 2 positive. Now I'm going to go back to my original, and I need 2 negative. So I'm going to subtract 360. This is going the other direction around my circle, going clockwise. And that would be negative 315 degrees. And then I'm going to do negative 315 degrees. Make sure you're writing the degree symbol every time on these. And that gives me negative 675 degrees. So it also asks for this thing called the general form. So to get my general form, I put where I'm starting, 45 degrees. And then what am I doing? I'm adding trips of 360 degrees. And I'm doing that, we write n number of times. N is any integer. So positive n would mean I'm going counterclockwise that many trips. A negative n would mean I'm going clockwise. So you can think of that n as just telling you how many trips did you do. So let's look at an example in radians. So for radians, it's just asking me to find one positive and one negative. So radians, I need to be doing pi over 6 plus 2 pi. But when we're doing fractions, we need a common denominator. So 2 pi is the same thing as 12 pi over 6. 12 divided by 6 gives me 2. So I'm going to do pi over 6 plus 12 pi over 6, which gives me 13 pi over 6. Pi over 6 minus 12 pi over 6, and that gives me negative 11 pi over 6. So I have a positive, have a negative. The last thing is general form. So put where you start. We're radians, so I'm going to do 2 pi. I could have also put my 12 pi over 6. That's totally fine. And then I put my n. That tells me trips around the circle. All right, pause and try the next ones if you want. Now, you may have noticed this is a little bit different. There are a couple ways to get different answers for this one. So I could do 480 plus 360 degrees equals 840. And if I wanted, I could add that 840 to another 360 to get another positive coterminal. But I noticed that 480 is over one trip around the circle. So I'm actually going to do 480 minus 360, which gives me 120. Because look, now I have my two positive coterminal angles. And that helps me get to my negative coterminal angles. Because now to do my negative, I already have this 120 degrees. And if I subtract 360, now I get a negative. Cool. And then I take that negative degree and go another 360 degrees in the negative direction. I get negative 600. So notice, how many times did I do subtraction? In this problem, to get 2 positive, 2 negative, I actually subtracted 3 times. So positive is about your end result being positive. Negative is about your end result being negative, whether you got there by adding or subtracting. My general form, just like before, starting point plus, we're in degrees, so 360 degrees times n number of trips. Last one, find a positive and a negative, general form. So 9 pi over 4, I need to be adding 2 pi. Oh, we're dealing with fractions. 2 pi is the same as 8 pi over 4. 8 divided by 4 gives me 2. All right, so I'm going to use that. So 8 pi over 4 plus 9 pi over 4. Switch the order of that, didn't mean to. So I got 17 pi over 4. Now I need to get to a negative. So if I'm subtracting, oops, look, I could have just done that one. There's pi over 4. Now we'll do pi over 4 minus 8 pi over 4, which is negative 7 pi over 4. So I have my positive, I actually have 2 positives, and I have a negative. It doesn't have to do with whether you added or subtracted, whether it's a positive or negative coterminal. And let's do our last step, which is our general form. So where did I start? 9 pi over 4. What am I doing? Adding 2 pi in number of times.